So in this handout, we're going to start at the beginning. I know that last week we started this handout in class, so for those of you that may have been here and have the problems worked out, go ahead and just fast forward to whichever problem you need to complete, and then the video that goes along with that problem. For those of you that may have been absent, we're going to begin here at the beginning. In the first four problems, you're being asked to answer some questions about trying to identify intercepts as well as the vertex. And then the goal here is being able to revisit enough topics from what we've talked about this year, or maybe even an Algebra 1 topic, so that you're able to complete problem number 5. So go ahead and take a look at problems 1 through 4 and see how much of that you can complete on your own. And then turn the video back on when you're ready to continue. And again, for those of you that have already completed this, again, fast forward in the video to the problem set that you're ready for. Alright, so for the value of y, for the x-intercepts, this is where the graph is always crossing the x-axis. And so when the graph is crossing the x-axis, this is where y has a value of 0. So that's the answer to the first question. X-intercepts is the value of x that creates 0 with these factors. And so for the first parenthesis, -3 would be the value of x. That would make that parenthesis equal 0. That's called the first 0 or root. And for the second one, it would be 4, since 4 minus 4 is 0. So this is the x-intercepts, also called the root. In problem number 2, it's asking for the x value, the y-intercept. So for the y-intercept, the x value is 0, and what we're looking for is the y value. So if I go back to the original equation here, y equals 2 times quantity of x plus 3, x minus 4. And since I already know the value of x being 0, for the y-intercept, I'm going to replace x with 0 to figure out what the answer would be. So I end up with, here's 0 plus 3, and in this second parenthesis, it's 0 minus 4. So I end up with this 2 times positive 3 for the 0 plus 3 times negative 4 for the 0 minus 4. So that means the final answer is negative 24. 2 times 3 is 6. 6 times negative 4 is negative 24. And so that would be the value of the y-intercept. So if you already know the x-intercepts, again going back to the problem number 1, the x-intercepts were -3 and 4, then how do you find the value of the x-coordinate of the vertex? So to find the x value of the vertex, we're looking for the value that's exactly between -3 and 4. So if you think about a number line where I have -3 on it and a positive 4, x value of the vertex is going to be that value exactly between the -3 and 4. So this point here, whatever that value is basically what we call midpoint. So if I take the -3 and the 4, and if I add those together and then divide by 2, that would give me positive 1 over 2, so positive 1/2. So 1/2 is 3.5 away from 4, and 1/2 is 3.5 away from -3. So it's exactly splits it in half. It's kind of like thinking about taking 2 test scores and trying to find your test average. You add the 2 numbers together and you divide by 2, and that will tell you the value that's exactly between those 2 numbers. Alright, so now we have the x value of the vertex. To find the y value of the vertex, we go back to our original equation, which is 2 times the quantity of x plus 3x minus 4. And what we're going to do is we're going to replace the x value in each of these with their answer. So I'm going to put that as 0.5 instead of 1/2. Oops, that's 0.5 minus 4. Sorry about that. So we have here is 2 times 3.5 times negative 3.5. So we multiply the last two numbers, so it'll be 2 times negative 12.25. So we end up with this is negative 24.5. So the vertex of this parabola will be at 1/2, which is our x value, comma, negative 24.5. So in problem 5, you're being asked to do the same thing. Go back to the first 4 problems, and you're being asked to find the x-intercept, the y-intercept, and the vertex. So work on those problems on your own, and when you're finished with those, move on to problem number 6. And turn the video back on when you're ready to continue with 6. Alright, so in this problem, we're looking at the general form of the different values or points that could occur on a parabola. So for example, at most there can be 2 x-intercepts. Sometimes the graph itself may be going up, but its minimum value is actually above the x-axis, so there isn't any x-intercepts. Or vice versa, the graph could be going downward, but the vertex itself is below the x-axis, again not giving you any x-intercepts. So every parabola has a vertex, every parabola has a y-intercept, but there may not be any real number x-intercepts. But for this discussion here, what we're looking for is based on the equation in general, where do I find the 4 values when we actually are writing it in factored form. And in factored form, we actually do have 2 x-intercepts. So go ahead and write down what you believe the answers are based on the first 5 problems, and then turn the video back on when you're ready to continue with the discussion. So in problem number 1, we looked at basically the x minus p, this factor here. And the question that I keep posing in class is what value do I put in for x here to make this thing equal 0? So if I add p to both sides, to actually rewrite this equation so that it's set equal to x, one value, or one x-intercept is p, comma 0. So whenever I have the value of p minus itself is going to give me an answer of 0. And then for the other one, it's x minus q equals 0. So again, if I same thing, if I add q to both sides, I get x equals q. So the other x-intercept is q, comma 0. Now for a y-intercept, this is where x is 0. Just like this is going back to problem, I think it was in problem number 3. Go back here and look, but problem number 2. We're actually looking for the x-intercept, or the y-intercept, so that means x is 0. And what we did was we placed 0 into this equation to actually figure out what the answer would be. So if I take y is equal to a, and then replace x with 0, so x would be 0 minus p. And for the other factor, also replace x with 0, so it becomes 0 minus q. What I end up with is a times negative p times negative q. And since I have two negatives under multiplication, that means the answer is going to be positive, and it's going to be a times p times q. So in terms of factor form, if I know the value of my p value and my q value, and then my a value is here in front, if I take those three numbers and multiply them together, that will tell me where the y-intercept is going to be. If I go back to the previous problem, here, for example, if you'll notice that I have a 2 here, this number is going to be 3, and here's a 4. Oh, sorry, this is negative 3 and positive 4. So if I take 2 times the negative 3 and times the positive 4 and multiply it together, I'm going to get a negative 24 answer. So here, this is half, or 0.5, this is 4/10, and this is 1. So hopefully you get the y-intercept to be, let's say it would be 0.20. If that's what you got here. And here, if you took 2 times, this is negative 3, and this is negative 4. So 2 times negative 3 times negative 4, hopefully, say you got two negatives makes it positive, and hopefully you got this answer for the y-intercept to be positive 24. Since 2 times 3 is 6, and 6 times 4 is 24. And then for the x value of the vertex, you're going to be going halfway between these x-intercepts. So if you take the p value and the q value and add those two numbers together and divide by 2, that's going to tell you the x value of the vertex. Very similar to what we did back here in this problem here. Took the two answers, the p and the q, and we added them together and divided by 2. So in problem number 7, I'll take a look at problem A and then give some time to work on the other problems. So it's asking you to write the equation, find the equation and the vertex of the problem with the intercepts. So intercepts we're looking at here is, these are the intercepts. This is the x-intercepts, and this is the y-intercept. So if I use the equation y equals a times x minus p and x minus q, since I'm given the intercepts, I can replace the p and the q with my answer. So this would be like my p value, and this would be like my q value. What we don't know in this problem is the a value, and that's where the third point, the y-intercept, comes in at. So we have y equals a times x minus 3 and for the other one we have x minus 6. So if I stick in 3 here, I'm going to make a 0, and if I stick in a 6 here, I'll get an answer of 0. So to find the a value, we're going to replace everything in the equation with the exception of a. So we're going to replace x with 0, and we're going to replace the y with 36, and we're going to try to figure out what is the value of a. 36 is equal to a times, so it's going to be 0 minus 3 and 0 minus 6. So 36 is equal to